array. The next array, also array related to array, but we searching for an element. And the rest is array, but now we sorting the element. So today, the first I spent about some minutes for review some important feature or important information for you about array in the last lecture. And that we move on to how to search for an element in the array, and now we study about the binary search, and we study how like that. And the main topic maybe today and the last in the next lecture is sorting about element. So now we move into the array review item. So the main we studied the array in the last lecture, but today the most important question for you is when we talk about array, what is the picture or what is the model about array? Okay, in your mind. Okay, when talking about array. Okay, so the most important question is what is model? When we think about array, okay, for easy to remember what is the model of array. Okay, I think that is the best model. When talking about array, you see that is the picture like that. Maybe here array contain or consist of the how many here? The 6 element, which index from 0, 1. Okay, when talking and array also had a name. Let's say about name A. Okay, name A. And inside of the item we had a value. Let's say for example some random value about integer. Let's say about an integer. Let's say 15. Let's say 5. Let's say 7. Let's say 21. Here is the model or the memory layout for the array. So for easy to understand or for easy to remember, I think that is the best model. When talking about array, we think about this. So some important feature of the array. I think first, the items, okay, the are stored continued in memory. In memory. That is more important thing. And that we can access item by using index. For example, we have array A, so we can access by using, for example, here is number 2 here. Here the square brackets, and then inside here the index. And remember that is really important. Why? Because by using index, and then in order to access or to go into the affected item, the executor perform very fast. Okay, so here we can very fast for accessing. important feature of array tend to this kind of the accession, and we call a randomly accessing. It means that why random? Because we can give the any item, any index, and then we can the executor can jump into that in item very fast, just by the equation here. DSA k equal to DSA 0 plus with k multiplied with size of item. It means that in order to access the item by the executor, if you want to, it means that for Reup view, in order to access the item, you have to perform this kind of operation. Here, for the executor of Java, or we call JVM, Java Virtual Machine. Inside of Java machine is do here. Very fast. The equation. And by moving it means what I mean. Here that the address of the first item. Let's say right now here the address of the item at index 0. Okay, index 0. Index 0. That is BTK. And then the executor always know, because why no? Because when you allocate or when you declare the array, and then when you allocate it, the executor only allocate, and then it's only keep the BTR 0, mean that the address of the first item. It's always know only. And now the user keep the, for example, k equal to 2 here right now in that. Here k is the index, and the size of item also only know. Okay, so let's say for the size of item, the executor also know. It know in advance. So when the user present k, okay, the programmer, okay, you present k, mean that index, and then the executor perform the expression, mean that it's easy to compute the address of that item, and then it move to the address the item you want very fast. So we call the random addressing. Okay. And for example, if in this case, we had a array. Here is the right. It is the array. So you only declare like that. The user declare in, for example, a. You have to use very important square bracket equal to, for example, let's say open here the 15 5, right here 15 5 7 21 so on. Okay. Okay, in array the user declare here in square bracket a equal to, let's say you initialize with 7, right? Sorry, I forgot it only. 15 5 7. (15, 5, 7, 21, 37, and 42. So let's say So from here, when the compiler is run this line or this code or the statement, and then the compiler know the size of item equal to 4 bytes. Okay, and by this initialization, then the runner or executor know BTR 0. Mean that the address of the first item mean that the 15 here. Because why? The compiler after compilation, it has to allocate the memory to store 6 items in the array here. So when it's allocated, it know the address of the first element. So it means that it know 2 items in advance. Okay, 2 information here in advance. So after that, the user, okay, in the user present k, let's say k equal to 2, and it's easy to compute the BTR2, mean that the address of the item with index equal to 2, mean that the 0, 1, 2 here, 7. And we also know that tend to the, because it stored here continuously, so that's why the block size of the whole block size, the size of whole block is equal to how many items here? We have 6 items, right? 5, that is the last index, so the number of items here is 6. Multiply with the size of item here is 4. That equal to 24 bytes. So that is the array. I want to give some information, the most important about array. Is it clear for you? Hello? So now we go to the next topic. Is about array. But we're talking about the binary search. Okay, we think about this problem. Assume that we had an array like this. Okay, let's say array A. Assume that we had an array here. Array this name A. And this array store about the student information. And then for each student, we store only the ID, the name, and the GPA. Okay, for you can store any kind of data in the item. But in this case, I think that we store only the array, in the array only about the ID, name, and GPA. Okay, if we had an array, okay, and now next, I think that we want to search for the ID. Okay, we want to search for ID. Let's say ID equal to 7. I sure for human, and then for only 3 items in the ball here, it's easy to identify because you know, okay, you easy to identify, okay, ID equal to 7 and then add index 1. Okay, anyone that is for human because we can use eye and we can look for the item very fast. That is for human. Okay, but let's say when talking about the searching, okay, when talking about searching, we have to I want to emphasize some information here. Searching in real application should have, let's say, we search item in the context that the number of items in the array very big. In real application, not only three look like three items in the ball. In real application, the number or the count of items is big. Okay. Let's say million or maybe several million. Not only three, okay? And even million items, and then for human it's also difficult. Okay? You can UI, but it's difficult. But for machine, it cannot UI. Okay? It can perform some algorithm for searching because, and then remember, but the number of items is big. And that, for example, we search for ID equal to 7 and it return, okay, given a key. Let's say right now a key in our problem, a key ID equal, let's say for example is 7. And then you return the index. If found in that, if found. Let's say for right now you return, let's say the found index equal to 1. And usually do you index here, you access to all the information. Let's say you index here, for example 1, you access to all the information, let's say name, let's say GPA or all the information. You search for key and then you get index, and next, usually next, how to use the index. Next usually you have to use index. To obtain the whole object, and then you guess or you accept all the information. Let's say all the information, let's say you had index 1, and then right now you accept into name or maybe GPA or maybe order. Because if you had a student with more information, you can get order. Okay, that is the real context for using the searching in real application. Okay, but usually for lecture and for you can read on of example in the book, on the internet, or even in this lecture, we simplify the item so the item only contain key. Okay. Remember, in real application, okay, we search for a key, and then we use key to access to all the information. But because if you draw on of information like that, it becomes the big picture. Okay, the picture becomes big, and then difficult for drawing or difficult to present in just one page of A4 or maybe the one slide. So that's why we simplify from now on. We simplify the item in just key. Just key or just the number. Remember, I mentioned that from now on we simplify the from now the array in example contain only key. Why contain key? Because we want to simplify the item. We need not to draw so much, right? Here, that is we go into the next slide. Now I assume that we had the array like this. So remember the array here is how many items here? The size is 6. Okay. Now the key is, let's say key 6 and key is, assume that we want to search for key. let's say 25. Okay, we define our problem here is now in this application, in this example, I want to demonstrate for the searching with binary sort. Okay, binary sort. For the key equal to 25. For human, simple, because we can look down array very fast for human by eye, and then we can identify, okay, 25 as cell with index equal to 3, you return 3. Simple for human, but actually it's not for computer because computer don't have eyes, right? Computers have perform some kind of algorithm. Now our algorithm we call the binary search. The question is how? Now I want to explain how binary search works. Hello everybody, can you hear me? Hello.
Yes, sir.
Now I want to explain how binary search working, right? How binary search working. Let's see. So for binary search, the first we call initialize. We use the left cursor, or we call the variable, and another variable we call right. At beginning, it means that we initialize with the left means that the index of the leftmost value or item. For example, in our array right now, the leftmost is 7 and with index from 0, and the rightmost is 42 with index 5. So that's why at beginning we assign left equal to 0 and right equal to 5, because we want to sort 25 in the range from 0, 1 until 5 right now. In example, okay, again, in example, okay, we know only 25 at 3, right? But we have to perform step by step. Okay, that is algorithm binary search. Now we start step 1. Or we call round 1. Or we call iteration 1. Okay. So we have a formula that we had one more variable we call mid. Mid means that the middle. Or we call m, right? We determine like here m equal to left plus right divide for 2. Mean that here is integer division. M mean that equal to 0 plus 5 divided by 2, that equal to 2. Because 5 divided by 2 for integer division equal to 2. Mean that m equal to 2. So next, okay, next we accept, we test a at m. We ask that equal key or not. It means that equivalent to, okay, m equal to 2. So a at 2 equal to 25 or not? You have to ask. Okay, and now we can see here is 17. Now on the right side here is 25. So you can see here important 17 less than 25 is not equal to it means that the middle item means not the at index 2 here. Now it's 7. It's different to the key. That is, we answer like that. And then we also know that okay, sorry, I have to give the 2 more information about array for sorting with array first. Sorry. Okay, let's forget it. I want to give two more information about binary search. In order to binary search that is the algorithm, and we have to satisfy two constraints here. Content for using array or for using binary search. The first, the data, okay, must store in array. Why must store in array? Because we need the random accessing capacity. Because need random accessing. The next, the element must be sorted. Okay, sorted. Maybe ascendingly, or maybe descendingly. But usually we have to focus on, we assume that already sorted with ascendingly. Right? So remember, before go to the, I want to explain how the binary search, but I want to give two more information about important information about the binary search. The first, the data must be stored in the array. Why array? Because we need the random accessing capacity. The second important, the item or the element must be stored ascendingly or descendingly. But in the remaining example, I assume that the item only sorted ascendingly, mean that increasingly. Now we go to the next here. Okay, we continue with the example. You can see now we know the 17. Okay, the item, the index, the middle. The middle now is equal to 2. The item is 17, less than 75. Okay. But we also know that the data in array only sorted in ascendingly, mean that the increasingly. And we know that the data increasingly. So the net route, we need not to sort on the left of 17. The net route or the next step, we need not to sort on the left of 17. Why? Because the left of 17 only less than 17. It means that also less than 25. So we need not to search on the left of 17. It means that we throw a half of data. Remember, okay, before so remember here, before continue. Okay, continuing with the with the net route. We throw a half of data. It means that we should only from what? From index 3, 4, and 5 only. And how? The question is how. It's simple. How to throw away? We just reassign. Right now, left at beginning the left equal to 0, and now with left equal to middle plus 1, m plus 1 equal to 2 plus 1 equal to 3. And sure, the right keep the same. Don't change it. Now fine. So we continue with the step. Next step. Step 2 or route 2. Okay, in route 2 we compute the m equal to left plus right divided by 2. Okay, I use the abbreviate simple. M stand for middle, L stand for left, and R stand for right. So that equal to 3 plus 5. Okay, divide for 2. That equal to how many here? 4. Okay, 4. So now we check A that at M equal to key or not 25. That equivalent to, sorry, here 20 M that the 4 that now is 38 with the versus 25. You see the now the middle or mean that the key less than the middle. Okay, key less than middle. Because why? We have 25 less than 38. Again, right now we throw again half of that term. Continue. How to throw away? We assign left equal to down 30 equal to 3. But right equal to left of mean that now emit subtract for 1 equal to how many? Equal to 3. Okay. We continue next step. Sorry, step 3. M equal to left plus right divide by 2 equal to 3. Now we take A M equal to key or not? That equivalent to 25 equal to 25, right? Here. Now left equal to 3. Right also 3. It means that here. So the middle also 3. The 25 now equal to 25 key here. So we found it, right? It means that equal, yes. The question is yes. It means that we found. It means that we have to return. Return what? We found M. Return M. That means that return M means that the value here is 3. You can see it's simple. We need 3 steps. We need 3 steps or 3 rounds. We need 3 steps or 3 rounds to find to search for 25. And now we had here we found the 25 here at in that tree. And remember in the previous, usually for reapplication we after found the index we use index to access the whole object, and then we access the field data field inside object. But now in example we just found that to return symbol M equal to 3 only. Okay, now simple like that. And okay, now right now another example. Assume that key equal to, let's say, 40. How to do? But before we go to the key equal to 40, any question? Is it clear for you? Is it clear? Can you understand my lecture? Hello?
It's clear, sir. It's clear.
Yeah, thank you. So now we go to the next. In this case, we return the positive the index because we found it, and the index example not found. Okay, for example here easy. You can search for human easy. You scan from left to right very fast, and then you see found 40 not found. Okay, but the question is how the better research step by step search for 40. Okay, continue. See the similar. That we initialize with L equal to 0 right now and A equal to 5 right now. Okay, the whole range. Remember, L means left, R means right. From left to right, it scans the whole range of data for searching. Step 1. M equal L R divided by 2 equal to, over here, 5 divided by 2 equal to 2. Next test. A that M equal 40 or not, right? No. And actually 40 rather than middle. Why? Because you can see M equal to 2. 2 means that 17. 17 less than key, or key less than greater than item at 2, right? At 2, right? So that's why you have to throw away a half of data. And how to throw? Left your side right now, because you see that because your key rather than the middle, so you need not to search on the left of middle. So now you change M plus 1, it means that 3, and A equal to 5, not change. Okay. After that, we continue with step. Next step, we compute M equal to 4. We test AM equal with the key or not, 40 or not. Now it means that A at 4 equal 40 or not? Equal or not?
No.
Remember here, A equal 38, right? A at the index 4 means that 38, but key 40, okay? Key still greater than key still greater than A at M. So you throw it away, a half of the data. It means that right now, remember, key still greater than, so you need not to search from not less than the item less than the middle. Okay, right now it means that you have to assign left equal to M plus 1 equal to 5, and A equal to 5, still 5. You go to step 3. Again, M equal to 5. Next, A that M equal to key or not? It means not. Now A that M is 5, right? So A at M is 42. 42 is greater than 40 key. Okay. It means that 42 greater than 40. It means that key less than A at M, right? Because the key 40 less than the 42, right? So it means that less than key at M. So the net, you need not to search on the right side of 42 or on the right side of middle right now. Middle is 5, right? Middle is 5. So we have to reassign LE. Now it's not changed. 5. Put A, we have to equal to M minus 1 because your key less than in the middle, so you have to search on the left of that is a-1, that is equal to 4. You go to step 4. Important, you see. Usually for each step, at the beginning of each step, but I not planned before, right? But beginning of each step, you have to text L less than R or not. Now not. Why not? Because if L equal to 5 is greater than I equal to 4. Here you stop with not found. You stop with not found, right? Not found. But the question is, assume that you define a function binary search. It must return the index. It must return that integer. So at for example here, when found, you return the valid index. Sorry. When you found it, you return the valid index, right? For example here, you return 3. Okay, the valid index that is positive, non-negative. No, non-negative, because positive means that from 1 to 3. Non-negative means that including 0, right? 0, 1, 2 on. So it return non-negative. Okay, non-negative. It's valid. And now you should not found how to return. How to return. Usually in Java, right? You have 2 class. That is class array. Java utility array. And another also collection. How it return? How you return a form? You can copy the idea, right? You can copy the idea. For when you found it, you return the valid index is non-negative value integer, but not found how to return. Okay, you can see Daniel. When you see before that the middle is fine, right? Before that the middle is fine. Okay, here the middle is fine. You can see here in step 3 the middle is fine. So you can return the embedded location for insertion. Okay, that value. Subtract this value and subtract 1. It means that equivalent to minus m minus 1. For example, in reverse example. In reverse example, you can see m equal to 5. So you return a minus 5. Minus 1 equal to minus 6. It means that you return minus 6. Is it okay? Because what I mean Wi-Fi m means that you not found at m. It means that the m is the expected location for insert. It means that now you search for 40. You can see in the picture in the my board here. You search the 40 and m is 5. What does mean 5? 5 here, right? It means that if you want to insert 40 into array, you insert in that file. That file. So that's why that is the expected location for insertion. Insert what? Insert key into the array. And now you find. Actually, that is the last m or the m in the last step. Here. So you return minus m minus 1. That is the way of the array and collection. That is the Java library. It do the same like that for you. So you return. Is it clear for you for the next example? Is it clear? Hello? Hello?
Yes.
Can you understand? Okay, thank you. So you can see that is the binary search. And then before we go to the demonstration by Java code, I want to perform analytics for some analytics for the binary search. So binary search. The question is how fast, man? How fast? The big question is how fast? How fast is it? Binary search, okay. This is very well now. How fast? And before we analyze, and then we had to mention that the two constraints for binary search. Two constraints for binary search. The first, the data must be stored in the array. Okay. Why? Because we need the random capacity, random accessing capacity. The next, the item must be sorted in ascendingly or descendingly. But in my example, usually and even in Java array or class, they assume that the element must be sorted ascendingly, right? Remember, in order to you. The question is how fast? Now we had an array like that. And we have many items here. We call the size of array equal to n. If in that 0, 1 until the last in that is n minus 1. Remember because we start from 0. And now we will form round, and that is size of data. What I mean round? For example, here in review example, we had after initialization, we had step 1, step 2, step 3, or we call round. All right. So at the first round, then we have to search on the whole data range without the n item. Okay, the size of data for searching means that the whole data range for the whole data range. But after the first round, we have to throw a half of data. Mean that we go to the step 2. The size of data only n divided by 2. Okay, because why? Because we only throw a half of data. And in the round 3, the number of here is n divided by 2, and you divide by 2 again, so n divided by 4. It means that equal to n divided by 2 power 2. For example, round 4, that is the size of data n divided by 8. That equal to n divided by 2 power 3. So I think that we continue with the round k. So the size of round k right now is n divided by 2 power. How many here? Hello?
2 power k minus 1.
Yeah, thank you. K minus 1. So I assume that we have to stop, right? So usually do have to stop at this. Okay, foul or not foul, you have to stop at this or after this step. So you have to stop when n divided by 2 power k minus 1 equal to 1, means that the data size only one item, right? So you have to foul it or we not foul it. Okay, so that equivalent to n equal to 2 power k minus 1. So equivalent to, you take log, so k minus 1 equal to log 2 of n. So k equal to log 2 of n plus 1. So assume that if you have the number, assume that n equal to, assume that n equal to really big number. Okay, assume that n equal to really big number. Let's say how many? 2 power 64. Really big. I think that the now our area we call a big data, but actually the number of data in the world, okay, maybe not equal to 2 power 64 because it's too big, right? And it's not equal to this. So how many rounds to perform to search for binary search? So k equal to log 2 of 2 power 64 plus 1 equal how many here? 65 only. You can see even the number of data is really big. The number of steps or the number of round or iteration is also small, only 65 or 64 or 66 only, maybe. Because why we talk like that 66? Because maybe you have when the equal to 1 means that the say equal to 1, maybe you stop right now, maybe you continue one more, okay, for empty, right? So you can see. So how far it is? How far it is, right? Now you can the number of iteration. You use the while loop or for loop, the number of iteration equal to k equal to log 2 of n plus 1. So you can infer that. Complexity, or we call it time complexity, equal how much here? Can you tell me what is the time complexity if we had a formula k equal, mean that the number of iteration equal to log 2 of n plus 1. So what is the time complexity? Hello? Big O of what? Big O of log 1, log n. Thank you. Because why? We have to the Reup the constant here. Okay? We have to Reup constant here. Or sometimes you need not log 2 because usually the complexity we should try, for example, big O of log n. You don't care about the base of the logarithm function also, because it's differently between we can change the log 2 to log base 10 of the other base, maybe just constant multiplication. Okay, that is the complexity for time. So about what I mean about the space complexity. I mean that the memory complexity. Big O of what? Can you tell me what is the space complexity? Hello. How fast is that? It's really fast. It's logarithm is fast only. Okay. And then now how about the space? If not how much memory you need to want to store the data. Thank you, Vinh Quang. Okay, actually, no, not constant. That is n. Why n? Because you need the memory to store the array, right? 0, 1 until n-1. You need the n item. Okay, you need the memory to store n item. So that's why it's easy to understand the complexity is big O of n. Hello, Nhân, are you clear? Hello, Nhân, are you clear? Not constant. Okay, not constant. Okay. Thank you. So, any question for me? Any question? Before we go to the next topic, any question? No? If not, I hope that you can understand the binary search. Very simple, right? Any question? No? Okay, no, thank you. So now here, what is it? Homework. What do I mean? Let's see. Homework. 1. You code binary search. In Java. Okay. Sure. To test it. Hello. So I think that is it's valuable for you if you can code it in Java. Okay, it's simple. So you can, again, in order to code, you can look at my video here. I will upload video, and you can follow. And you have to initialize L and R, and then you use variable M. We continue with step here. You're done. Okay. Simple. Now we go into the demonstration how to do it. Sorry, I had to close some window. Close on. Can you see my desktop? Hello. Can you see the NetBeans API IDE? Hello.
Yes, sir.
Okay. So in array lecture 2, I think. Now I use, again, as I told you before, you can use binary search in Java by import. First, sorry, quite slow. Java.utility.array, because you have two array, two library. Okay, let's say you can search for Java array. Here, remember array we had S, right? Oh, no. Why is it like that? Learning now. Here array. Here Java utility array. You read document. You can see it support many API for you to search on the binary array. Can you see binary search in the document from Oracle? Can you see?
Yes.
So at home, you just use the Google to search for keyword Java and then array, and then you look down the document You read some API here, and then you know how to use it easy. For example, if you sort the array of the, let's say, array of double, how to? You use this API. You pass the first parameter in the array, and then the next is the key, mean that double. And that is maybe not useful. I think that is better useful. Here, if you want to search for an array of student or array of table or array of laptop, right? Mean that the array of user-defined class. Here, this API. You can see. Can you get the API? Can you get that? What is the how many parameter? 1, 2, 3, 4. What, can you guess? Can you guess the first parameter meaning? That the array you want to search, right? From index to index mean that the left and the right? Okay. And what I mean the last? The last is the key, mean that the object you want to search. Okay. And I think the more important here is the binary search with that API. Because why? Because usually for the object T of type T may be student. Do you know how to compare to student? Actually, if you don't tell anything, the Java don't know. Java virtual machine don't know how to compare to student. And if you don't tell anything about the laptop class, and Java virtual machine also cannot understand or cannot know how to compare to. So that's why you have to develop the one class called comparator to search for, to compare two items inside of array of type T. So that's why you can pass the first is array, the two net is the left and the right, okay, and the third, the fourth parameter is the key object, and the last one is the object for comparison. So another, you can Java collection, the similar. Here, Java collection. Okay. It also had an API for you. Okay. To here on the super interface iterable. Here you can see not collection is not the interface. Okay, as here. You can see we also had a binary search here. And similar, we search for the list, right? For example, array list. In the last lecture, we studied about array list. So remember, array list actually is also inside that is array. Okay, and it's simplified for the user or the programmer many tasks. Now we'll after look at the document, and now you go into the example. Let's say I run it first. We had a class binary search. We had a main function or the entry point. We had a class, the BS means that the binary search simple or called a simple demo. But we call demo here. Can you see demo? We just run it, and then what you can see what happened. You wait for some minutes for compilation. Waiting for some minutes, please. Okay, before that, we go into the code, and you can see in simple demo, I create a symbol ascending, means that increasing the array. By what? Here, I had an array with integer, and because I use collection, so I use the array list here right now. So I create the array list from the array. Okay, I add item E into the item here into array. So after that, I bring out the array and I call binary search. And for example, I bring out 78. I search for 78. I bring out the index of 78 and 15 and 35, so on, right? And order. Let's see what happens. Okay, quite slow. I had to stop some application. Please. Okay. Here. So we had a array like this. The first row here index 0 to 7. The item is increasing. Remember, increasing order, right? I must emphasize that the data is in the ascending order, 10, 15, so on. So you can see 78 here at index 5. You can see 15 at index 1. Correct. 35 at index 2. And 5 at index minus 1. So why 5 at index minus 1? Can you tell me? Why 5 index 1? Remember, it return if not found, when not found. Then return the subject for the affected log subject minus 1. So now you back to here, you can see 5. You look at the array here, not found, right? But if you want to sort array in the 5 into array, it should be at index 0. So the return is return. It return here is. Sorry, why like that? Why like that? Can you see? Hello, are you there? Hello.
Yes.
So
Yes.
I want to explain why when you search for number 5, the library return minus 1, because the affected location for insertion is 0. So minus 0 minus 1 equal to minus 1. Okay, you have to wait for me some minutes. Hello? Hello, are you there? Hello.
Yes.
Okay. So now, for example, if you want to search for 38, you can see at human, right? You can see 38 at industry, right? If you want to insert, you have to insert at industry. So minus 3, minus 1 equal to minus 4. Okay. Around, for example, 80 for human. Okay, sure. Remember, when you apply binary search, you get the value of middle. You just take negative of the middle and then minus 1 and then you return. Okay, but now, okay, sure, the middle now for 80 equal to, for human, 7. So minus 7 minus 1 equal to minus 8. Okay, and again, for if you search for the 100, so the middle should be A. So minus A minus 1 equal to minus 9. Okay, that's why the API here return you the binary search here return like that. Okay. Now, so okay, for really simple for using array of collection to perform binary search. But again, you should element by yourself using Java by yourself, not compare, not using the collection or array, because you have to element it and then you have to understand how the binary search working. And that for advanced BS without a binary search in another example. And run it. So back to the, I want to explain how it works. Here in that example, I want to store the array of students. I want to store array of students. So for simplification, the class student contain only name and GPA. In real application, it contain many more information, but now for simple. So I create the constructor is ratio. It can help you to create object student with name and GPA. And we have, because that is reverse, so we have to should provide a getter for GPA, and also for toString to support printing. And sure, because if you had integer, if you had double, if you had character, and then on of search data type support natural order, it means that the GPM how to know the Java virtual machine, how to know to compare two values of such kind of data type. But for your out data look like student, sure, the Java virtual machine don't know how to compare. Okay, don't know how to compare. Even the human, you also tell me, in this application, maybe you can compare by student ID, student name, GPA, or maybe order. But in this application, I want to compare by GPA. So how to do? I developed one class called the student S with that student comparator. You can name whatever, but you have to element the class, the comparator, and then you should give here the item type is student. So when item type student, so the first parameter and the second parameter of the compare method should be student, must be student. Remember, if here is data type for, because the comparator is the generic class, so you have to specify the element type. Now student. So the compare method here should be the first and second should be the student. And actually the compare return 3 value only, minus 1, 0, and 1. Easy for 0. When S1 means that student 1 equal to student 2 in your our view. Okay, so you return 0. If student 1 less than student 2 in your out view, you return minus 1. And otherwise you return plus 1. Okay, the comparator only that is that is interface, not class. in this interface here, a very important the method called the compare. This method return integer, and then the semantic of this method is that it return mode 1 when the first less than a second, 0 if the first equal to second, and otherwise you return mode 1 plus 1. So in our application, I want to compare based on the GPA, so that's why I do like that. S1 get GPA subject for S2 get GPA less than 0. Less than 0, it means that you move S2 to the right side. It means that the S1 less than S2 in GPA, right? So you return mode 1. L, you test and with greater than 0, you return plus 1. And otherwise you return 0. It's equal. Right? So it means that we already know the class, we already had a class to support comparison of two students. To support comparison of two students, how to do it right now. And similar, I create the symbol array. I create an array list. I add the first, the second, the third, and I add 4 students called Long, Phương, Bắc, Bãi, right? With the GPA of 545, 745, and so on. And remember, I want to emphasize that the GPA now already sorted increasingly. 545, 745, 845, 945, I mean that increasingly. Okay, increasingly. So how to sort? By binary sort. Easy. You create array, you print it, and you sort for array. The first is the array you want to sort inside. And the key objects, now we don't care about the name, right? Because we just use about the GPA. So I pass here is 646. And then, the third parameter, I have to pass the comparator, object of comparator. So you can see it's run it and it's done. This row, we have 4 students. Remember, increasingly in GPA. Đông, Phương, Bắc, Bãi, right? So now I search for 646. 646, 545, 745. Oh, okay. So 646 at index should be found at index 1, but now it's not found. Now not found, right? Should be found at index 1, but not found. So you take negative in minus 1 and you subtract 1, that equal to minus 2, you return. So for the user, when return negative value, it means that not found, and then you can infer where is it also, right? Is it clear for you? Hello. Hi. Hi. Are you there?
Yes.
Is it clear for you? Hello. Okay.
Yes.
Okay, it's clear, right? So now, so you take break, right? You take break about 15 minutes and come back here. 15 minutes and come back here, please. 15 only, right? So around 55, okay? 55. 14:55, come back here, please, right? Hello.
Okay, sir.
Yeah.